Okay, this is the second question. It is very smart and useful question. Okay, we have a hill. Its height is h is equal to 6.2 or tall 6.2 meters. This is h. We don't know the angle theta. We don't need to know the angle theta. We don't need to find the weight mg and cosine and sine theta. It is just we need the height and some things like this. Just it is simple when we use energy. The mass is 5.7 kilograms. If this mass lift from point number 1 to point number 2 in 30 seconds, it is easy. We need to find the power to lift this from here to here in 30 seconds. Okay, we can find the potential energy at point number 1. I think it will be 0 because h, if we take this as the reference point, h equals 0, then the potential energy at this point will be 0. The potential energy at the second point, the second state, is equal to mgh. M is 5.7 is given. G is known as a magnitude. H is also given is 6.2. Then the potential energy at this point, which is the maximum point, the maximum energy is 346.3 joules. If we need to calculate the power, then we need to find the change in potential between 2 points, which is the same as the work, which it is the work, and not divided over the period of time, which is 30 seconds. So 346.3 minus 0 over 30, it is 11.5 watts. Okay, now we need to remember that always we are dealing now with a conservative force. We have a mechanical energy is equal to kinetic energy plus the potential energy due to gravity. At point 2, the velocity is 0. The velocity here is 0. The body is stationary. So the kinetic energy is 0. So all the mechanical energy is equal to the potential energy now, which is 346.3 joules, which is always constant. Okay. Now point B, we need to find the velocity if this mass released and we need reach the lowest point again, and we need to name this state 3. It is not the same as state number 1 in this case, because there is a person lifted to this point and there is no velocity here, just there is a work. Now this work converted to potential energy, then this potential energy will convert to kinetic energy. So if the body has a velocity here, and if the body has kinetic energy, then it has velocity. We need to find this velocity. Okay, the mechanical energy, total mechanical energy at point number 3 is equal to the mechanical energy at point number 2, which is 346.3 joules. And now we can find that as we did in the previous question, the mechanical energy is equal to the kinetic energy plus the potential energy at that point. The kinetic energy is equal to half mv squared. It is the formula. The potential energy, we need to know that the height at this point is 0. It is the 0 level. So the potential energy mgh is equal to 0 because h is 0. But the kinetic energy is not 0. The kinetic energy is equal to that total mechanical energy. Half m 5.7 v squared speed squared. Okay, we need to order it multiplied by 2 divided over this quantity, then the velocity squared is equal to 121.5 meters per second squared, as we told you before. Squared because the velocity is squared. The root of this value is 11 meters per second approximately, okay? We need to find that positive value. And this velocity we don't need to talk about it is in x direction, it is in y direction. We don't know, because I draw the level in this way. Maybe you will draw it in this way. Maybe another one will draw it in this way or in this way with different thetas. Okay? So the velocity, it will be along or parallel to the hill. We don't worry if it is to the east or to the west or how much theta. We don't need that. We just need the velocity. It is simple, more simple than the previous part in this class. Okay, this is the velocity, 11 meters per second. Okay, now if this body after reach this point, the minimum point, point number three, yes, go and move over a friction level to reach point number 4, and the friction coefficient mu k is equal to 0.17, unitless as we know, because this is grass or something like that. How much the distance? Now we need to use the mechanical energy formula with non-conservative work. The work due to non-conservative forces. What is the non-conservative forces now? It is the friction force. We know that the friction force is equal to mu multiplied by the normal force. And the normal force is equal to mg in magnitude. M is 5.7, g is g. Then the normal force is equal to 55.9 newtons. The kinetic energy here is 0 at point 4. We are talking at point 4, at the last point. At point 4, the body is stationary because it loses all of its energy as a friction because of the friction. So the velocity is 0, then the kinetic energy is 0. The potential energy, because H is the 0 level, is 0, the potential energy due to gravity. But the work, now where is the energy go? Where is lost? Which is 346.3 joules, the potential energy from the first question here. It goes and lost as work for the friction force. Okay, the work is equal to the force. We know that work is equal to force multiplied by d cosine theta, because F in this direction and D in this direction, then theta is 180, cosine is -1. The work is equal to negative value. We need to the magnitude, the negative value, because it is lost. Okay, now the energy is equal to the force is equal to mu n, as we find it here. D is D. We need to find D. N is known. Mu is known. The energy is known. Now, the energy is 346.3 is equal to mu. This is mu multiplied by N multiplied by D. We need just to divide on this quantity. Then D is equal to 36.5 meters. That is because of the friction force. This is a smart question. You need to know how to find the potential energy, how to find the kinetic energy, also to find the velocity. We don't worry about the theta. We just need the altitude or the height or the tall of that level. And then we can also find any energy or work due to friction force or non-conservative force. This is the second question. Thank you.